Hello everyone. Today we're going to be talking about solving logarithmic equations. So logarithmic equation is any equation that involves logarithms of variable expressions. So for instance, log 2 of x is equal to 7. That would be a logarithmic equation because we're taking a log with a variable in there. And something that we can use to help solve these equations is the property of equality for logarithmic equations. And this tells us that if b, x, and y are positive real numbers with b not equal to 1, then log base b of x is equal to log base b of y if and only if x is equal to y. So for example, if I see that log base 2 of x is equal to log base 2 of 7, then that means that x must equal to 7. And so this property tells us that we can take an equation x equals y, exponentiate each side, and get an equation of the form b to the x is equal to b to the y. And so I see my equation started as x equals y, but now my x and y are instead the exponents of my same base of b. So we're going to use that concept when we are solving these equations. So this first one, I have the natural log of 4x minus 7 is equal to the natural log of x plus 5. So first I can look at that and I can see, okay, well, using my property of equality, since I have this natural log on both, this tells me that the inside of them has to also be equal to each other. So that means that 4x minus 7 is equal to x plus 5. And the reason why is if I can go ahead and cancel those natural logs by taking that base of e. So I could do e to the natural log of 4x minus 7 is equal to e to the natural log of x plus 5. And those e's and natural logs would cancel out. And then you end up with that 4x minus 7 is equal to x plus 5. So that's why this kind of works. Anyways, going on to solving this equation, when this subtract x from both sides, and I get 3x minus 7 is equal to 5. And then 3x is equal to 12. And then divide both sides by 3, and I get that x is equal to 4. Okay, looking at number 2, I see this is really similar. I have a log base 2 that I'm taking on both sides. So since I am taking the same log on both sides, that means what I'm taking a log of has to be equal to each other. And again, I kind of think of it, I can take the power of 2 on both sides and they would cancel. Either way you want to think of that. And so I get that x plus 11 is equal to 5x minus 17. Subtract x from both sides. And I get 11 is equal to 4x minus 17. (28) is equal to 4x, and then divide by 4, and 7 is equal to x. Okay, now these next two look a little bit different. So I'm not having that same log that I'm taking on both sides. This time I'm going to have to do a little bit of different steps. I want to go ahead and show you two different ways that you can think about this. The first way is using that same property. And that property tells me that I can exponentiate both sides. So I know to get rid of that log base 2, I can have it be the exponent of base 2. And so what I'm going to do is I'm going to take this base 2 on both sides, and what was in my equation is now going to become my exponents. So what was in my equation became my exponents, and I'm taking that base 2 on both sides. And so the reason why I did this is because 2 log base 2 cancels out, and I end up with 5x minus 17 is equal to 2 cubed, which is 8. Add 17 to both sides, and we get 5x is equal to 25. then divide by 5, and you get that x is equal to 5. So that's one way you can do it. Another way you can do it is actually to rewrite it in exponential form. So log base 2 of 5x minus 17 is equal to 3. We learned a few lessons ago that we can actually rewrite this in exponential form. And so I have that same base 2. What's equal to is your exponent. And then what's inside the log, it goes on the other side. And I say I end up with that same equation, that 8 is equal to 5x minus 17. And we know when we solve that, we get that x is equal to 5. So either way works when you do this. I'm going to go ahead and stick with that first method just so we can get more practice with how we can get rid of those logs using inverses. Okay, now this last one that one we'll do for this video is log of 5x plus 5 is equal to 2. So we need to remember when we just have log, there isn't a number written there. What is our base? We have to remember that our base is actually 10. And so here I'm going to take 10 on both sides. That's my base. And my equation here is going to go into my exponent. And so when I take 10 raised to the log, that cancels out and I'm left with just 5x plus 5 is equal to 10 squared, which is 100. Subtract 5, and I get 5x is equal to 95. And then divide both sides by 5, and I get that x is equal to 19. Again, if you wanted to use this other method, you could have skipped to that 10 squared is equal to 5x plus 5 and solve from there.